let's talk about some cool properties of logarithms. So, first property is that if you add two logarithms, say like log 2 plus log 3, the addition outside the logarithm actually turns into multiplication inside the logarithm. So it turns into log of 2 times 3, or just log of 6. So that's super useful if you're simplifying a long log expression, like if you had log of 2x plus log of 8 plus log of 14y. Well, actually, let's change that. Something easier to multiply. Log of 10y. Then that would just become log of 2x times 8 times 10y, or just log of 160xy. So that's a pretty handy trick for condensing down logarithm expressions. The other trick is if you multiply something like, say, 2 log of 3, you can turn this 2 into the exponent of this. So this could be written as log of 3 squared, or just log of 9. And it goes the other way too. You could write log of 9 as log of 3 squared and turn it into 2 log 3. So you could turn like 8 log x plus 3 log y. You could turn that into the log of x to the third plus, or x to the 8th plus log of y to the third, and then using the addition rule, that would become log of x to the 8th, y to the third. So now, a consequence of this rule is that negative log of, say, negative log of 2, that's equal to log of, that's like negative 1 times log of 2, which is like log of 2 to the negative 1, which is log of 1/2. So by putting a negative in front of a log flips the fraction of whatever's in the log. So like negative log of 5/3 equals log of 3/5. Now another consequence of this is that log of, say, 3/5, that's log of 3, then plus log of 1/5, which is log of 3 minus log of 5. So division is actually subtraction between logs. All right, let's practice expanding and condensing some log expressions. So first, let's condense an expression. Let's condense 3/2 log of root x plus 2 log of 1 over y minus 3 log z, log of z plus 1. Okay, so first step in condensing, let's move all of these exponents to the variables. Well, first let's write everything in terms of powers. So this is like 3/2 log x to the 1/2 plus 2 log 1 over y, or let's write that as y to the negative 1 minus 3 log z plus 1. And then we can take the exponents, put them outside maybe. So this becomes 3/2 times 1/2 log x plus 2 times negative 1 log y minus 3 log z plus 1. So that's 3/4 log x minus 2 log y minus 3 log z plus 1. And now let's do, so that's log x to the 3/4 plus log y to the negative 2 plus log z plus 1 to the negative 3. So that then final answer turns into the log of x to the 3/4, y to the negative 2, z plus 1 to the negative 3. So this would be our condensed expression for this. Now say we wanted to expand out a logarithm entirely. Let's say we had, let's do log of 3xy over 3xy squared over square root of z minus 2. So how do we expand that? Well, that would turn into log of 3xy squared minus log of root z minus 2, because remember, division is subtraction. Division inside the log is subtraction outside the log. And then we can turn this part into log 3 plus log x plus log y squared, and then minus log, let's just write an exponent on this, z minus 2 to the 1/2. So that's log 3 plus log x, let's take the exponent out in front, plus 2 log y, again let's take the exponent out in front, minus 1/2 log z minus 2. So that would be our fully expanded form. Forgot a plus there. Yeah, that'd be our fully expanded form. Yeah, so these properties of logs let you expand logs and then shrink them back. And they'll come in pretty handy for solving logarithmic and exponential equations.